Binomial distribution. A binomial distribution is a kind of discrete probability distribution. But what is a binomial distribution? Let's imagine that there is an experiment. The experiment has two outcomes. One outcome is called success. The other outcome is called failure. Each time when we do the experiment, the probability that success appears is a constant. We use lowercase p to represent this probability for the success to appear. Of course, the probability that failure appears is also a constant. It's 1 minus p. Imagine if we do the experiment n times, we can infer that in the n times, sometimes are success and sometimes are failure. Each time when we do n experiments, the number of success are random. For example, today we do an experiment, maybe n minus 10 times are success. And tomorrow we do an experiment, maybe 15 times are success. So the number of times for success is random. So the times that success occurs is a random variable. And in such a case, we see that this random variable follows the binomial distribution. We use this expression to represent that a random variable follows a binomial distribution. In this expression, the x represents the times of success. This is the random variable. This symbol represents follows, and this part represents the binomial distribution. Here, n represents the number of experiments, and p represents the probability that success occurs in one experiment. But what is the detail about the binomial distribution? What is its possible values, and what is the probabilities for each possible value? We can infer that the possible values can be 0, because in the n experiments, it's possible that no one experiment is success. And the possible values also can be 1, because it's possible that in the n experiments, only one experiment is success. And the possible value also can be 2, because it's also possible that in the n experiments, only 2 experiments are successful. And so on, 3, 4, until n. Because it's also possible that all the n experiments are success. So now we know the possible values for the binomial distribution. But now, what's the probability for each value? For example, what's the probability that the random variable equals 0? So what's the probability that no one experiment is success in the n experiments? What's the probability that that only one experiment is success in the n experiments, and so on? So now let's consider a specific example. For example, Rolling a fair six-sided die is an experiment. We think that the experiment has two outcomes. One is that number 5 appears. Number 5 appears. The other outcome is that other numbers appears. Other numbers appears. So for one experiment, the probability that number 5 appears is 1 over 6. The probability that other numbers appears is 5 over 6. Now we suppose that a die is rolled 4 times. Then the times that number 5 appears is a random variable, which follows a binomial distribution. We can write it like this. X represents the times that number 5 appears. This follows binomial distribution. In here, the number of experiments is 4, so 4 here. And the probability that success occurs in one experiment is 1 over 6, like this. Now, for this binomial distribution, what is the probability that number 5 appears 2 times in the 4 experiments? That is, the random variable equals 2. What is the value of this probability? Now let's analyze this. Because we do the experiment for 4 times, so we list them here. First experiment, second experiment, third experiment, fourth experiment. So for number 5 to appear 2 times, it can be the first time that number 5 appear. For number 5 appear in one experiment, the probability is 1 over 6. So we write 1 over 6 here. And the second experiment, number 5 appears again. And for number 5 to appear in one experiment, its probability is 1 over 6. We write here 1 over 6. And for the third time, its other numbers appear. So the probability that other numbers appear in one experiment is 5 over 6. We write 5 over 6 here. And for the fourth time, it's again other numbers appear. So the probability that other numbers appear in one experiment is 5 over 6. We write here. This is one case. The probability for this case happen is here multiply. This equals 1 over 6 square multiply 5 over 6 square. This is one case. And also, it also can be the first time number 5 appear. Its probability is 1 over 6. And the second time, other numbers appear. The probability is 5 over 6. And the third time, its number 5 appear. The probability is 1 over 6. And the fourth time, its other numbers appear. The probability is 5 over 6. So the probability for this case, first number 5, second other times, third number 5, fourth other numbers. So the probability for this case to happen is again we multiply it. So this also equals 1 over 6 square multiply 5 over 6 square. Still, there are also other cases. For example, it's first time other numbers appear. Second time, other numbers appear. Third time, number 5 appears. Fourth time, number 5 appears. This is also 1 over 6 square. 5 over 6 square. Because the probabilities of all the cases are the same. Now, if we can find the count of all the cases, then this calculation would be simple. In fact, we can choose 2 experiments from the 4 experiments, and we let number 5 to appear in the 2 experiments we choose, and let other numbers to appear in the other 2 experiments. Recall the knowledge of combination. There are 2 ways to choose 2 experiments from 4 experiments. In each way, we let number 5 to appear in the 2 experiments we choose, and let other numbers appear in the left 2 ways. The probability of each way is 1 over 6 squared multiply 5 over 6 squared. We multiply these 2 parts. So this is the probability that the random variable equals 2. From this example, we can deduce the probability for the possible values in a binomial distribution. So we conclude that for a binomial distribution P, the possible values are 0, 1, 2, until n. And the probability for each possible value is this x equals r. This equals, here is n, here is r, and here is p to the power of r multiply 1 minus p to the power of n minus r. And the expectation for a random variable which follows binomial distribution is equals n multiplied p. And the variance for a random variable which follows a binomial distribution is n multiplied p multiplied 1 minus p. For these 2 formula, we just remember them. But for this formula, it's better for us to know how it comes, how it is this way.